So yesterday, whenever we are discussing about the inputs, outputs, right? Let me share this screen first. When you are assigning the values, it is like it is to drive the values. We use wires, right? And registers to hold the data. Every time we are keep on changing, all the possibilities are changing, right? Possibilities are changing, and every postulates of the clock, you are changing the values. The sensitivity list whenever you have called, so it is changing. No? That is the reason it has to hold the previous data until next value. For example, you are checking the first data. What is the A equal to 0, B equal to 0. So next after 1 unit of time, you'll be going to change the value like a B equal to 1 0 or else 0 1 1 0 1 1 like that, right? So every time it is changing my input. Random inputs are changing all the time. So that is the reason you have to define all the inputs as a ledger type and all the outputs as a wire. You got it, Manoj? I think we already discussed that part yesterday. Yeah. I'm sharing this screen. Is it visible? No, not yet. What is the file name we gave for the test bench yesterday? This one. So I think 3 or 3 students. Shall we start session, yes? All of you. How to join the full course? You just talk to administrator. You just call to institution and ask them. They will provide some information regarding that. Raju, call to the institution. And because reg will be stored values, for storing the values, we will assign. See, here is the example. Giri Prasad and Manoj. Here is the example. You can see for the first unit of time, I'm just randomizing this data. I'm just applying the values higher 0 0 0 0. All the inputs I'm making 0. And the next unit of time, I'm checking the next possibility. So what are all these things inputs, right? That is the reason inputs we declared as a reg. Because every time my possibilities are changing, all the random values, we are applying the random values. No, that is the reason you have to declare it like this. And by always continuously driven, whatever the input, the result you are getting, you are assigning the value to the output. Is it clear, Giri Prasad? Here is an example. The reg we declared. In the next unit of time, what is a possibility? You guys can tell me. I equal to 0. When manually initializing this one. Whenever I'm manually initializing the values, it is like this. So nobody is following this kind of linear test bench as of now. Okay. Nowadays, everybody is applying the dollar random. Tool will generate the, what is dollar random? I will write here. How to go to the last page? Last line of my page. Instead of moving cursor like this, how can you go to the last line of my tab? Did anyone remember? Capital G. Very good.
Hello, ma'am. Please maximize the screen. Hello. 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 Where is my office? Hello.
Is that okay?
Okay.
So if you guys have anything in between session, you just drop your comment in the chat box. I can check it and I can correct it. Okay. Yes. So now this is the linear test bench. So we are nowadays this is the advanced concept. Dollar random generates the random numbers, signed random numbers, right? Signed means what? Both positive and negative random numbers. (32-bit). Okay. So now it is the we update the dollar random yesterday, and I'm commenting all these lines. That is not part of our code. To make you understand, we have written there. So apply #1. Now display. Yeah, WhatsApp channel number is there. No, you can call to them. I will provide the number. Wait a minute in the channels. Raju. After the session, I think while leaving the session, you can drop such kind of questions. Okay, let me send the number. You don't have the number?
Hello, ma'am. I think at 6 anyway we'll have an announcement for the participants. So we'll share the number later on.
So Raju, you got it right? So I just wanted to print the outputs, inputs, I0 in a format specifier using %d, decimal format. %0d, I2, 40%0d, and 3. %0d, S0, S1. And y also I need to print, right? Y equal to %0d. So how many format specifiers to print inputs and outputs? How many format specifier we used here? 1, 2, 3, 4, 5, and 6 and 7, right? So those many arguments I need to pass it. Otherwise, it will shows the error. How many format specifiers you declared here in the braces? Those many arguments you have to pass it here. So I0, I1, I2, I3, S0, S1. Now the test bench is finished. It is done. We don't have any clock and reset here, as it is a combinational circuit. You don't need to declare the clock and reset. No need to end the simulation as well because it doesn't have the clock. So the test bench is completed. Now, gate level simulation, right? Yesterday we were talking about we discussed data flow modeling style. This is the behavioral style we completed, one example. And one more thing, gate level. For that, we required the structure of the, how do you draw the structure of any circuit, digital circuit? How can we draw? Let's do one dot V. Can anyone? How do we get the structure of the Boolean expression? Gate level. I only said that answer. So module name. Module name is mux21. So what are the inputs and outputs for the mux21? Yeah, by using logic gates. But to draw the logic gates, you should have the Boolean expression, right, Sushmita? I0, I1. How many inputs are there for the 2 cross 1 mux? I and S. Okay, I0, I1. Because we are writing in the scalar form. So that is the reason separately we are writing. If it is a vector form, I can write only I comma S. Okay, right? So I0, I1 and S comma Y. These are the inputs and outputs. And
She said I got from mail from AICTC.
input I0, I1, S. And output. Do I need to declare the output as a reg? I said I will run this code today, right? Do I need to declare the output as a reg when I'm implementing the gate level? No, not
No,
required. So
No.
not required. Only for the behavioral style, whenever we are using the always procedural block, the output must be declared as a reg type, because
Reg,
every positive edge of the clock, we are changing the values, right?
Yes,
So
yes.
that is the reason. Can you please be mute? So that is the reason you have to declare them as a reg in the behavioral style. So here, no need of procedural block for the data flow on gate level, no need of declaring the output as a reg type. So I will share another screen. I hope you all know how to draw the circuit diagram, right? Based on the Boolean expression. What can be the Boolean expression for the 2 cross 1 mux? S0 bar
S0 bar I0,
I0. Then
S1, S0
where is,
I1.
yeah, where is S1 come from? No. Wait.
Yes, not S not.
Yeah,
Yeah.
S0. No, I'm sharing on the screen. Wait a minute. S0. And here in between we have the AND gates. Dot means AND gate, right?
Hello.
Yeah.
Yeah. We mentioned S not S not. S bar and S, not S not.
Okay. Not S. Very
Yeah.
good. S bar I0, S dot I1, right? This is the, how many gates are here? Tell me the gates here.
2 gates,
How
ma'am.
many gates we can? Only 2 gates.
AND gate, OR gate.
2 AND
AND
gates
gate.
and OR gate.
Where is
Not
the
gate.
NOT gate
gate,
is
not
also there. You have written the S bar, which means that you have NOT also, right? 1 NOT gate and 2 AND gates. 2 AND gates and 1 OR gate, right? So I wanted to share the screen. It's okay. I hope you know how to draw the circuit diagram, because it is not supporting me to share it. Again, I need to log in. If you give me the 2 minutes of time, I can share the diagram. I will tell you how to draw. So until it gets open, we can discuss here. So how to do the instantiation of the gates? How many gates we discussed? NOT gate and AND gate and OR gates are there. So here we have to draw the two lines, and one is I0, one is I1, and another line we have to draw as a S, and you have to give the AND gate to that one, that is the S bar, right? So how to do the instantiation of the gate? First gate name, and the some instance name, and then port list. In the port list, output must be first. You have to write output whenever you are doing the, especially for the gate instantiation, output you have to write first. Otherwise, it will gives you the high impedance. That is the reason output you have to write first. Then only you can write the inputs. This is called instantiation. Gate instantiation. How to do the module instantiation? Yesterday we have seen the DUT, how we have done the instantiation. I just wanted to share the screen for the diagram which I have drawn yesterday. So I think it is taking time to share it. That's the reason I'm discussing. How to do the DUT instantiation? We implemented the two test benches for the 4x1 max and other yesterday we implemented, right? One is data flow and the behavioral style. How we have done the DUT instantiation in that? Module name, some instance name, and port list we declared. Through port declaration, okay. Port declaration, inside the braces you are writing. You are connecting the ports, test bench ports to the DUT ports you connected. We implemented two styles of connections, right? Yesterday, what are those? One is connection by position and other one is a connection by name. So industries prefer the connection by name only. Why? Because if it is the multiple, there are more number of inputs and outputs, the signals are there. You can't remember the order whichever you have declared inside the design. So that is the reason industry prefers the connection by name only. So whenever you are writing the connection by, no need of again and again, you no need to go to your design, what is the order of your, how you declared inside it, you no need to check it. So any order, whatever the inputs and outputs, shuffle the order and connect it. Can anyone share the screen, or else my system is not supporting to open the pane? Because I should have to explain that one. Otherwise, you guys may not understand how we are writing, how we are instantiating, right? Can anyone, student can share the screen, open the pane? I will guide you how to draw. That one is better because it is taking time from my side. Meanwhile, everybody can get the Boolean expression for the in the chart box. I think we already have written the fifth line. S bar. Can anyone student can share the screen?
Yeah, I share. Hello.
Where we can see that, right?
Hello.
Hello.
Yeah, I can share. I share.
Yeah, you can share. You shared already, but it's not visible.
Not visible. Not visible.
Guys, you can see his screen.
Yes, ma'am.
Okay. I said I think I should stop.
Shared, no?
Yeah, I think, yeah.
Already shared.
Maybe.
Hello?
Yeah,
Yes,
yeah.
ma'am.
Maybe. Yeah.
Maybe.
Yeah. That one only. You can open otherwise. Any paint, you can open it. Not from the Google
Paint.
or else anything.
Hello?
Yeah.
Yeah, I shared paint also. I opened paint.
Yeah, just draw 2 lines. I think if everybody can watch your screen, I can guide you. Just draw 2 lines. Give the names as I0, I1 and I0.
Madam, now it is visible to us. Is it not
Okay.
visible?
Okay. Some other person can share the screen.
I don't know how to write this.
Not this good. Yeah, here it is good. Now. So you can draw 3 lines, guys. Girish.
Girish, not me.
Draw
Girish,
3
not
lines
me.
quickly. No. Vertical lines.
Hello, I drawn a vertical lines. Hello, ma'am.
You just, can you please be in mute, Ravi? Because it's already shared the screen.
Oh,
Later I can talk to you. Okay.
okay.
Girish, you can draw the 3 lines, vertical lines.
Okay, ma'am.
Roughly, you can draw 3 lines between. Take a brush and brush is there, no? You just draw 3 lines, vertical lines. Vertical, horizontal. Yeah. Give first line as a I1. Enough. First line is I1. First line you can write quickly I1, I0, S. Write the line number. First one, you just give the line number names. I0. First, you can take a maximum. MSP, you can take left hand side. I1. No. Don't do that. Just use the brush only. Quickly we can do, right?
Okay. Okay, ma'am. Okay.
Roughly you can draw. Yeah. I1. Because my side it is not opening. I1. Yeah. I0. Next line is I0. Next line you can give the S. S. Next line. Third line you can give S. Selection line.
Okay.
Okay. Just take from S to horizontal small line. You can draw small horizontal line from the S. Small line. Yeah. Yeah. Small line. Inside. Okay. Drop down again. Come down. You can draw another line vertically. Yeah.
From here.
From that only, where you ended the line. Yeah. Just give and not get. Just Control Z. You can give the Control Z. Yeah. Draw it again. Small line, I said. Small line.
I'll remove this then.
Yeah. Small line is enough. Yeah. Again, drop small line and draw the one not get there. No, you know not get, right? Small line. Yes. Horizontal line. Yes, very good. That one. Not get. Give the yeah, very good. Drop down. Yes. Now, what is the expression we have written right there? left side corner, you can write the expression S naught, S bar I1. Write the Boolean expression somewhere. S bar I1. Small letters you can write, no?
Yeah.
S bar I1 plus, yeah. It's okay, let it be. Whatever you are continuing, continue like that. S bar I1 plus Si0. This is the Boolean expression we have to draw on that line. So first connection is what it is saying, S bar. What is the S bar line here? This is the S bar line. Whatever the not get line you are taking, no, that is S bar. S bar means W. That line is, it doesn't have name. That is the reason you have to give the W. Name it as a W. Whatever the not get line you have given, no. Below you can write W. But you have to draw a lot of things. Can you maximize that? Yeah, W. Okay. Now draw the line. What is the connection? S bar line. Draw horizontal line from the S bar. W line you can write from W line to horizontal line. You can take it. Very good. Yeah. I1. The next expression is I1, right? I1. From I1 to draw line. Yeah. Write the draw the AND gate there. Horizontal line, vertical line and get D. D you can write. Very nice. Now extend the lines I1 and I0 because we have to draw some other things, right? Extend the I1 and I0 and S as well. Next expression is what? S. S and I0. Connect the S and I0, draw AND gate. S line you can take first. S, because above you have written S first, right? That is the reason. S, yeah, I0. AND gate. AND gate. From these two, you can draw, yeah, connect these two with the OR gate.
OR gate.
Yes, very good. Yeah. So write the OR gate. Very nice. This is the output. What is the output? Y you can draw. You have to draw output as a Y. The OR gate. Expand, no? That one. You can drag. Yeah, Y. Now, in between, we don't have the names here. Okay. So, what is the output of the first, Girish?
Ma'am, yes, ma'am.
First AND gate output, we don't have the name. We already have taken one wire here. That is the S0 we have taken as a W, wire name, right? And the D1 output and D2 output, which means that AND gate 1 output and AND gate 2 output, you just take it as a W1 and W2. W1, output of the AND gate, W1. And below W2. So we have 3 wires here. One is S bar and the output of the AND gate, output of the, keep it aside. Now this is the diagram. Everybody can take the screenshot and keep it with you. Now we will write and connect the connections. Everybody should understand. Otherwise, here only you can write Girish once. How can I connect this one? When I'm instance, can you please be in mute, Girish? So whenever we are instantiating everybody should answer what I'm asking. So whenever you are instantiating the NOT gate, output we have to write first. Whenever you are doing the gate instantiation, the output must be, have to declare first. So what is the output for the NOT gate here? W, right? W. So what is the input for that one? W comma S. So first NOT gate, write in the chat box everyone. NOT gate of W comma S, like that you can write it. And like that, every connection you have to write now in the chat box. Very good. Purna. So not gate connection is W, S. What is the AND gate whenever you are doing the instantiation of the AND gate 1? So everyone almost correct only, but everybody missed the instance of that name. Okay. But whenever you are doing the gate instantiation, you have to write declare the output first and the input later. So gate name, some instance name we have to get. Now let us see. You can stop sharing, Girish, because everybody got the expressions right. That's it. You can stop sharing, Girish.
Yes, ma'am, I stop.
Okay, maybe. Okay. Is my screen is visible?
No,
Yes,
ma'am.
ma'am.
No. Hello, ma'am. What happened? Hello.
Just a few minutes. Wait. Actually, I thought she lost connection. Just a few minutes.
Okay.
Hello guys, before ma'am joins, I have few announcements to make. So how many of you are liking the workshop? Like, can you guys react, raise your hands, or you want some changes? How many of you are liking it? And how many of you are part of our community, the Silicon Sandbox? Have you guys joined the community? We have a community where we post VLSI related jobs. So if you haven't, you can join. We'll share the link and all the credentials, the mobile number, and our website, everything in the chat section. And we have a art like this workshop is just very beginner friendly or something. You can't learn complete Verilog or complete DV and RTL design in just 5 days, right? So we have a 6 months course that's completely online. It's complete RTL design and verification. So if you like this course, or if you want your friends to join, if you want to learn more about it so that you're job ready, because no VLSI company hires people directly, so they need trained freshers. So if you are interested, I'll share the credentials, the website, and the numbers you should contact. You can just reach out there, or else you can stay after the workshop today, and you can ask any doubts you have. And also, we know that not everyone can afford higher courses, so we've reduced the fee of the course, which was actually 16,000, is now at just 10,000. So if you guys are interested, you can just reach out, and I can assure you that you'll not find such good courses at that price anywhere else. So if you are interested, you can just reach out to us or stay till the end of today's session. I think ma'am has joined. She'll continue.
So when I'm trying to share the screen, it is denying. It is showing that it is you can't share the screen. Is it visible, guys, online?
Yes, ma'am.
Okay, so now this is the instantiation. Okay, gate name, some instance name we are writing. So what is the connection? First one is W, S, and the AND gate. And gate G2, some instance name we are giving. What is the second output of that one? We gave that W1, comma, S, comma, I0 or I1. First AND gate we have taken for this line, right? So another one is AND G3. So W2, S, comma, I0. So the second AND gate. These two are connected to the OR gate, or some instance name you can give. So G4, Y is the output, and W1 and W2 are the inputs of the two AND gates, right? Those are connected to the OR gate. This is how we have to do the gate level instantiation. So whenever you're doing the gate instantiation, we know that output has to declare first. Otherwise, we'll get the high impedance. So now let us implement the test bench for it. What's unless max2 underscore eb dot v. So what is the first step? You have to include the design file. So max21 dot v. So declare the top module, title top, end module, or else any name you can give. Okay. So fetch. So I0, what are the inputs and outputs? You can go and check the list here. I0, I1, comma S. And output you have to declare them as a wire type Y. So now DUT instantiation, max21 DUT. So I0, I1, comma S, comma Y. So now you have to drive the values, apply random values. Initial in the initial process block, you have to drive the values, concatenate all the inputs I0, I1, comma S. Dollar random. Give some delay. Dollar display. I0 equal to percentage 0t. And equal to percentage 0t, comma S equal to percentage 0t, comma Y equal to percentage 0t. I0, I1, S, comma Y. So like how we have to do the all the abstraction levels we have seen until we don't want to bother about the switch level, right? That is for the backend. So PMOSes and NMOSes we are not going to discuss here. So now let us run these codes. We have to create one file here, SPL run.to file. So I just wanted to run the file max21 first. Verilog, this is the compilation time. So Verilog, tb.v, vsim, elaboration time. So during the course, you can learn what is compilation, what is elaboration, what is a simulation. Okay, I hope in the introduction we were discussing about the simulation and all. So compilation also. Basic PB module name. And then run hyphen on. What is the file name of the max41 testbench file name? We have given max41 underscore TB. That name we have to pass it. Max41 underscore TB.v. The module name we have given as a C. So go to wherever you saved your files, take this path. In the transcript window, So quit minus C. That will ends your previous simulation. Whatever the earlier simulation you are working, you just have to quit it. Whenever you want to run new simulation, you just have to quit the previous simulation. CD space create the work library on each and every design. Sorry for the delay, guys. I think it is waiting. We need to run doc. Yeah, Sushma. Always model sim will take time. No, you raised your hand. That's the reason I called you in. So it is generated the output here. You just unlock this transcript window by clicking on the middle button. So here, this is the output. So every output will be, you have to check like this. Copy the output and paste it in the Max Testbench. Let us analyze it. So this is the output, I0, I1. This is for what? So I0, I1. So it's based on the selection line, right? S0. If it is S0, what it has to the output? If S0, what it has to print? There are two selection lines are there for 4x1 marks. S0, we haven't print the two selection lines here. Go to the display. S0, S1 we are printing here, right? Are we getting the S0 and S1 and S0 in the result? No. So it is printing the gate level. Okay. Maybe above this one I have a file. So it is the result for the gate level. At least anyone, we can run 4x1 marks as well. So this one is S0. If it is S0, what will be the output is? If it is S0, I0 should select. What is I0 is holding? 1. So that is the reason Y is printing the I1. Okay. What is the I0 is holding? That 1 we are getting. So if S equal to 1, which means that I1 should select. I1 is holding the 0 here. That is the reason we are getting the Y0. So here again check another possibility, S0. If it is S0, I0 should come out. I0 is holding the 1 here. So that is the reason why we are getting as a 1. So marks 41 underscore tb.v. This is marks 21 it is printing. because above this I have a file. I will close it and I will run only the mux 4.1. So this is the mux 4.1 and we included the file in the Testbench mux 4.1. So create the run.2 file again. The file name whichever we have taken, that is mux 4.1 underscore tb, correct only. Mux 4.1 tb dot. This is the file name. Here in the black line we can see mux 4.1 underscore tb dot v, and the module name you have to pass it VSIM underscore tb. That is. Here we run that code like 2x1 marks. Maybe gate level it is taking. That is the reason only one S selection line it has shown. So I think shall we do the project tomorrow? Whatever the project we are discussing about, we completed all the abstraction levels using all these styles. Shall we implement the project tomorrow? Because I kept all the files in the same folder. Yeah.
Once again, show me simulation, how to simulate this and waveform.
Waveform, do we have the clock here to see the waveform? See, this is not the sequential circuit, right? If you want to see the waveform, add wave, hyphen, position, insert point, sim, slash, tp, tp. This is the command we have to pass it. But we don't have the waveform. We can't see, right, for the combination circuits. We can only see, we can also run this one, but we don't have the clocks and all to get the waveform. That is the reason this, whenever you are working on the sequential circuits, use the third line command. Okay, this command you can pass it. And you can see that experience tomorrow, whatever you are asking, no, you want to see the waveforms and all. So we'll be going to implement the memory for tomorrow, so that there we can see the outputs and inputs, how many, exactly how values are reading at the positive edge of the clock, and how your writing and readings are happening at the different clock cycles. You can see that. Okay. Yeah. Is it clear? This is the commented line. In the rundown to double comments are not working. Okay, it won't work. Like however you have commented this line, this won't work in the rundown to. So you just have to give the hash here. So whenever the sequential circuits you are implementing, if you want to see the waveform, you just have to give this command. So any doubts as of now? Guys, is it clear? Do you have any doubts on abstraction levels, data flow, gate level, and this one, behavioral style? No. So we'll implement one project on the Verilog, and we'll have the intro of the SystemVerilog tomorrow as well, along with that project.
Ma'am, do we have to install the model sim first?
Yeah,
Not
you
getting-
have to go, yeah, you have to install it. Student version is available in the Google. You just Google it and download it. First download and then install. It is free for the, no need to pay for it. Student version, you can pick it and download it.
Which path we have to give?
Just type modules in download for the Windows, what is this, Windows 11, whichever the OS you are using, type like that.
I am talking about the path which you gave of the file, like for the mux gate level.
Which path? Okay, that is no. Okay, in your drive only. Somewhere you are writing, right? How to open the, for example, you are working. See, I will show you what out I understand. So some drive you want to save your file. Just go to D drive, open it, and you have to open a folder here. Sandbox assignment. And you can open like this on name of the assignment folder. So here you have to take it. Okay. So however you are working here, this path you have to paste it. You will be going to work here, right? You are opening one text editor. So you'll open one GVIM text editor to write the code. Every code you are implementing here. So this path you have to select. This is the D drive partner. Wherever your files are saved, wherever you are working, that path you have to take it and paste it in the transcript window. This path. You got it now? See, I have written your codes here. This path I have taken. Okay. Is it clear? Any other student is having any doubt? I hope I can wind up the session then. If you don't have any doubts, we can wind up the session. And we'll see the project and introduction of the SystemVerilog tomorrow. Already have the Vivado installed in my system. Okay. So if you better to run the RTL is supported. This is model sim is better for it. If you are working on the SystemVerilog UPM, you can go with any other tools like that. Model sim you can download. It is free version available in the Google Drive. So you can download.
Thank you.
Shall we wind up the session, all of you?
Yes, ma'am.
Please suggest me one Verilog project. So Verilog project will be going to implement tomorrow. Swati, memory. Yeah, Quastasim also you can run, Sandeep. And Quastasim also you can run. If you have Quastasim, you have to give some different commands there in the Quastasim. Here you have to give the some Quastasim paths like this. Okay, you're running, right? See, wait a minute, I'll show you. If it is Quastasim, you have to pass something here. No here. You have to no to optimization. Okay, no here. Hyphen suppress 12110. Then TP. That's it. This command you have to use it for the Quastasim. Advanced RTL design modification will talk in this manner. In this manner, can you just check with the management, Bhavya? Can you please show me the command in the command records? Okay. You want me to share the command? So no vlog. Yeah, Bhavya, you can stay after the session. Ansha was telling you, so you can stay back. That's it. Shall I leave now? All of you? Yeah, thank you, everyone.